everyone. I'm your host of Shortcuts, Adam Dudley, and today we're going to discuss how to transform your vulnerability management program with the power of asset metadata and automation. So this topic is very exciting because it's critical to moving a vulnerability management program from dysfunctional to functional and successful, and sometimes from impossible to possible, because in the case where there's human resource limitations, you need to use automation to get vulnerability management done, which is a very complicated process. So our expert guest on this topic is an experienced and deeply technical, savvy field security engineer. He's also a Signal Sciences alumni and has a side hustle programming lighting and effects for music shows, which I think is very cool. Please welcome Aaron, or A2, as we call him at Nucleus. Welcome, Aaron.
Thank you for having me. Appreciate it.
Awesome. And Aaron, I decided not to pronounce your last name there because why don't you pronounce it for the folks watching at home?
It's Aaron. It's Attarzadeh. It's a long last name.
Yeah. All right. I always would prefer my guest to pronounce their last name if it's challenging. Cool. Welcome. And before we dive in, can you give us a quick take on what asset metadata is and why it's important in the context of vulnerability management process automation?
Asset metadata ranges from things like who owns the asset, who supports the asset, the different applications that could be deployed on that asset, if that asset is running or it's been deactivated. Moving into a highly hybrid cloud and on-prem environment these days, you have a mislinkage of data that really you don't know if it's running or not. And as we're moving into more so ephemeral style environments with the introduction of Kubernetes and containerized environments, you have environments that are constantly going up and down every single day. So ensuring that you have this metadata there so you can properly allocate vulnerabilities to the respective teams. You can ensure that the correct vulnerabilities are in fact being remediated by the correct people, and you're not chasing down an asset that is no longer even active and wasting precious, valuable time during a P1 issue. So this is asset metadata that can realistically come from anywhere. We're talking CMDBs, spreadsheets, and also the scanners that your teams have spent so much time in putting together asset grouping rules in services like CrowdStrike and Tenable and Qualys. So people have tried in the past, but the issue is you have all this dispersed metadata across all these different environments, and actually keeping those different fields up to date is a challenging task.
What I heard there is that asset metadata are various characteristics on different types of assets. They might be application type assets or cloud resources or even devices. Mm-hmm. And when I think of asset metadata, I think of properties, properties on an asset that you can, that's just additional information that you can use to have more context about that asset.
Take Kubernetes, for example. You have a team that deploys the image. You have a team that maintains the instance itself. You have a team that writes the code, right? So it may all boil up to a single EC2 instance that's vulnerable to said vulnerability. And it may pop up in your VM solution that, hey, this EC2 instance is actually vulnerable to this. But unless you have the asset metadata that shows you who wrote the code, who deployed the image, who built the CI/CD pipeline, you won't know who to actually send that vulnerability to. So all this information everywhere at Nucleus, our goal is to consolidate this and able to automate based off of vulnerability type, vulnerability source, data source, and et cetera, to ensure that those vulnerabilities are getting to the respective people.
That's great. Thanks for that additional context. And so really what it means is that a big part of vulnerability management, especially in a large environment, is who's responsible for what? Like who's responsible for this asset and the different components of it. Mm-hmm. So thanks for that summary. So would you please share some ideas on what vulnerability management problems that leveraging asset metadata and automation really solve?
Working with a few customers right now where they have a number of on-prem environments, a number of on-prem instances, and these on-prem instances are just single VMs that are deployed in a hypervisor on top of a hypervisor. But the teams that manage the underlying hypervisor versus the teams that manage the VM itself versus the team that manage the network that those VMs are actually talking through are all different, right? And utilizing our ServiceNow CMDB connector, what we've done is we've been pulling relationship data of all the different applications and all the different teams that are being involved on this asset and bring that into Nucleus. And then you leveraging leveraging findings processing rules inside of Nucleus, we're able to key on the different types of vulnerabilities and then autonomously assign those vulnerabilities to the respective teams within ITSM because we have this Nucleus ITSM app that's already built into the store. So we're able to write custom business rules that dynamically assign the correct vulnerabilities to the correct teams when you, again, only see one VM in Snow based off the CMDB information. But if you go up an additional level and you look at the relationship table, all that relationship metadata is coming into Nucleus. So that's like one quick way of how we're doing that. And then even building on top of that is, the assignment of those vulnerabilities is one thing, but also setting the risk of that asset, right? So you have all this metadata that's coming in, where it's deployed, what it's touching, this sensitivity of the data, if it's external or internal, that we're getting from all the different firewalls, all the different CMDB information, even spreadsheet information that people can push into Nucleus. And we're able to normalize that data inside Nucleus and then autonomously map that to risk attributes that are on top of the asset, right? So we have business criticality, data sensitivity, publicly facing, and if that asset is in scope for compliance. So we're autonomously mapping those metadata fields that we're getting from all these different sources to the risk attributes in Nucleus, setting a risk score that's highly customizable based off of your own business metrics.
Right.
That risk score is then being used to calculate SLA dates, right? So take, for example, you have, let's say, a Raspberry Pi, and that Raspberry Pi is sitting on your desk, and it's a test bench for you. And it has the same exact image that you're using as a test bench as an image that's potentially in prod or in staging. That Raspberry Pi is going to have the same exact vulnerabilities that instance that's deployed on an EC2 instance, for example, what that same image has, right? But the difference is the criticality of that asset for the Raspberry Pi is nothing. It's a Pi sitting on your desk versus that EC2 instance that is publicly facing. It's in production. It's highly available. So then now you have these two vulnerabilities that are sitting inside a Nucleus. One of them is risk 1,000 versus one of them that's risk 100. We're setting the SLAs based off of the risk value of what's most critical to you, not just what the severity of that vulnerability is. So that way, we're not cluttering up anyone's feed. We're not upsetting anyone. So to me, that's kind of the most important part of Nucleus, is ensuring that we're getting the information to the right people. We're not cluttering people's feeds, and we're not giving them false positives. We're ensuring that they have the correct information they need to remediate those vulnerabilities in a timely manner.
At the risk of sounding cliche, we're helping our customers to surface the signals and the noise so that they're not distracted by a bunch of irrelevant information and vulnerabilities that really aren't as critical as they might think.
Correct.
Yeah, thanks, Aaron. So now let's actually take a look at some examples in Nucleus and really look at, in a demo environment, how Nucleus customers are using asset metadata to create fine-grained automation rules. When we come into Nucleus, if we jump into the asset management window and we look at the right-hand column here under source, you'll see that for some assets, there's 3 logos listed. So the first thing Nucleus does on ingestion is actually correlate assets from different data sources together, right? So you have assets that are seen by CrowdStrike, Tenable, CMDB, and Qualys. Those are all the same asset. So rather than having 4 separate assets in Nucleus, we correlate them and create a single asset record. And then if we click in on a single asset, and we scroll down, you have all the metadata from the various sources. I mean, we right now we just clicked on a CrowdStrike asset, but as you slowly start to gradually add more data sources, you will have additional metadata listed here. On top of that, you leveraging our AWS connector, you can add live AWS information from all the running instances, all the running containers into Nucleus that's updating in real time from instance uptime, security groups, tags, ownership, IDs,
account information. All that information can be leveraged and dropped onto assets as well. Now, if we take a step back, we'll see here that we have risk attributes. These risk attributes are completely customizable based off of the metadata you give us. So either you give us metadata, or within Nucleus, we can manually set these as well. Those risk attributes tied to the active vulnerabilities are what give you your risk score. If we jump into automation, we can talk a little bit about how this information is being set. If we click on add rule, you have a breadth of all these different asset metadata fields that you can key on, from the metadata of the asset to the OS, to the risk attributes, to the host name, to the IP information. All this can be grouped in a single rule. So you don't have to create rules per individual data source. You can say Qualys, CrowdStrike, Tenable, and Rapid7 all in one rule. If it hits on this criteria, I want to go into my actions menu and I want to set business criticality, and I want to set this to critical. On top of that, let's say you already have this information in a spreadsheet or in your CMDB or in a tool of some sort. You can leverage dynamic fields to dynamically set this information on the fly. Every single time we ingest, we're ensuring that that asset that was notified to us as a critical is being kept as a critical.
Correct me if I'm wrong, but if the information changes in the CMDB, for example, then that dynamic field will automatically update as well.
Correct. As assets are being downgraded or upgraded, those values are changing. So making sure that that critical asset is staying critical, or if it's being deprioritized to a medium or to a low because it's been taken out of prod, you can deprioritize that dynamically so you're not being boggled down with critical vulnerabilities, right?
And does that apply to ownership as well? So if ownership ownership property changes in the CMDB or whatever the source of the asset metadata is, then Nucleus is automatically going to update that, correct?
Exactly. All metadata fields on an asset, all asset ownership fields on an asset, risk attributes are all dynamically updated on ingestion every single time. Some of the rules that we have in place right now to just prioritize a vulnerability, leverage Mandiant, but you can group both Mandiant information in addition to the vulnerability information that's ingested from the scanner. Again, all data is normalized here. So you can see here that I'm not keying specifically on CrowdStrike vulnerabilities or Qualys vulnerabilities or Tenable vulnerabilities. I'm just clicking on the name of the vulnerability.
Right.
Also being able to group both Mandiant information on top of that, as well as EPSS or CISA BOD. And then leveraging things like risk attributes, right? So I can key on business criticality down here and prioritize based off business criticality. Any of the metadata fields that you see on an asset, you can key on in these prioritization rules.
And that allows for very detailed rule creation, right? I mean, this is super flexible. It can suit pretty much any environment in any way the customer wants to design these.
Oh yeah. I've had customers that go really, really granular with bringing their own matrix, their scoring matrix into Nucleus.
Right.
I've also had customers that leverage 4 or 5 Mandiant prioritization rules, and they take their 20 different rules down to 5. And that's just to prioritize the vulnerability, right? That's not to actually assign SLA and the speed of remediation. If we come down to actions, we can jump to the findings, right? So you can create a rule that says, hey, if this is a Windows style vulnerability, I want to assign it to the Windows team. What if there's 20 different Windows teams? What if there's 20 different images teams? All that asset metadata that's coming from your CMDB spreadsheets, X, Y, and Z can all be dynamically used to assign to their respective team without you actually keying on which team. I mean here, if you simply just write a query that says any type of vulnerability that is a Windows style vulnerability, I want to assign it dynamically to the Windows team, but this field Windows team is a different team for every single asset. So this is all this is doing is just keying on the metadata field in an asset called Windows team, but the actual value of that field can be Windows team in Arizona, Windows team in New York, Windows team in Florida, right? So you're only writing a rule once, but being able to dynamically assign it to your hundreds of teams that we're seeing on assets. This is kind of like the aha moment for a lot of customers. because in ITSM, one of the pain points is you have to create that mapping of what goes where. So we have that information, and then we can set the criteria here, and we support both regex and regex style queries, wildcard queries, contains queries, where you can say it contains PHP, Java, Golang, or Python. That would go to my images team. Images can be 40 different teams, and we can just write asset.images team. And now you dynamically assign those to said 40 teams, and you're only managing one rule. Let's talk about how to actually set SLAs. So down here, you'll see I have two rules setting SLAs for vulnerability for assets that have, assets and vulnerabilities that have SLAs of greater than 750. And then I have another rule here that says assign SLAs for assets that are 500 to 749. What this is doing is it's not looking at the severity of a vulnerability. It's not just looking at the severity of an asset. It's looking at both of those combined. So it's saying this critical on this asset gets an SLA of 3 days. Versus this critical on a Raspberry Pi that has a risk score of 100 gets an SLA of 90 days. So now we're hitting on both asset criticality and vulnerability criticality tied together. And rather than managing 40 different rules to specify all the different keys, you just have 5 or 6 rules that go through the range of what your internal organization's SLAs should look like.
The topic of ownership, comes up a lot in vulnerability management, and a big win for asset metadata is being able to define and consolidate that ownership in one central location, because that's where vulnerability management really gets complicated and tricky if you don't know that ownership.
Vuln management is it's not an easy task, right? When we think of prioritizing vulnerabilities, when we think of assigning vulnerabilities, as we're progressing from a more monolith style environment to microservice architecture, assets are becoming more ephemeral, being more horizontally dispersed. But the main thing is you actually have more information about assets than you really think you do. If you actually sit down and think about who owns the security group, who owns this IP range, X, Y, and Z, you don't need to know everything right out the gate. Within Nucleus, you can segment certain rules to certain asset groups, and you can try these rules out with a handful of assets, ensure that, hey, this is exactly how I want this to work. And then with the click of a button, you can scale it out to more assets. So easy remediation, easy to get up and running.
Thank you so much for joining us today on Nucleus Shortcuts, and we'll share any relevant links in the show notes. And we'll see you soon for the next episode. Thanks, Aaron.
Cheers. Thank you.